In this video, we will solve the questions asked in UGC Net Economics paper of 2024 of December session, which was held in 2025. The question is, if the government expenditure rises by $100, total revenue rises by, that is the total tax revenue rises by $100, the value of the marginal propensity to consume is 0.5 and there is no change in the autonomous investment and consumption. In a simple Keynesian closed economy model, GDP rises by, options are being given, we need to find out the correct option. Okay, so we are being told that the change in the government expenditure is $100, tax revenue increases to $100, marginal propensity to consume is 0.5. we need to find out how much the income rises using our national income identity, that is our total income will be equal to the consumption expenditure plus investment expenditure plus government expenditure. Okay, so our income will be equal to, what is consumption, that is A plus B times Y minus the tax revenue. Okay, what what is disposable income, that is the total income minus the taxes paid on that very income. So this denotes our total taxes here. So A plus B, YD is this very term, so YD is equal to Y minus D, plus investment is autonomous and government expenditure is being given as is. Rather we are not being given the government expenditure. Okay, solving it further, so we have Y is equal to A plus, so B marginal propensity to consume is 0.5. Can I write 0.5 times, or let me further explain it, so it becomes by minus bt plus I naught plus g naught, rather g. Okay, that gives us our total income is equal to A plus, what is B, B is 0.5 y, then we have minus B, then we have again we have minus 0.5 times D plus I naught plus G. Okay, now take differential on both sides, that means, or first let us transpose this term here, so we get Y minus 0.5 Y is equal to A plus, rather minus 0.5 T plus I naught plus G. So this sums up to 0. Or rather this subtracts to 0.5 Y is equal to A minus 0.5 T plus I naught plus G naught, rather G only. Now let's take the differential on both sides. Okay, so we have 0.5, differential of Y is del Y is equal to, so since no changes in the autonomous investment, so the differential of A will be 0 minus, we have 0.5 times the change in tax, that will be del T, plus autonomous investment is also being told it is autonomous here, rather there is no change, so the change in I naught will be 0 plus, but there is change in the government expenditure, so we'll write it here del G. Okay, so we have del Y, 0.5 del Y. Okay, let me write it here, so we have 0.5 del Y is equal to minus 0.5 del T plus del G. Okay, so the change in the government expenditure, that is 100, so we can write 0.5, sorry, change in the income is to be found out. Now we have minus 0.5, the change in the tax revenue is 100, so we write del T is 100 plus change in government expenditure is 100. Okay, sorry for the mistakes that I do. So can I write 0.5 is 1 upon 2 del Y will be equal to, so minus 0.5 into 100 is minus 50, plus we have 100, so we get del y is equal to, here it is 50, transpose this, it gets multiplied, so we get the income will rise by 100. Okay, so let us see how do I take the differential here, because the change in the income, that is del y, here we are being told that change in investment is 0, so I wrote it here 0, that it is constant. Okay, similarly the change in the autonomous consumption, what is A denotes the autonomous consumption, that's why we have 0 and 0 here, and the change was only in the tax revenue and government expenditure. Okay, the question is, if marginal revenue of a firm is $10 and the price it charges per unit is $30, assuring that the firm is a profit maximizer, what is the own price elasticity of demand for the firm at that point of profit maximization? Options are being given, we need to find out the correct option. Okay, so marginal revenue of the firm is equal to $10, that's being given us. The price it charges per unit is 30, so price per unit is being given us is $30. Also we are being told that the firm is profit maximizer. Okay, we need to find out the elasticity of demand, that is price elasticity of demand for that very firm. Now we need to find out the relationship among price, marginal revenue and elasticity for a profit maximizing firm. We use the Lerner's index. Okay, Lerner's index, or simply we know the relationship is being given us is, that is average revenue minus marginal revenue upon average revenue should be equal to minus times 1 upon the elasticity of demand. Okay, we know this relationship. Now what is average revenue? Average revenue is nothing but price, so can we write here price, here also price, so this is the relationship. Solve. Now price is 30, marginal revenue is being given us as 10, divided by 30 will be equal to minus 1 upon E, so 30 minus 10 is 20, divided by 30 is equal to minus 1 upon E. Okay, that gives us, this gets cancelled, so we have 2 upon 3, or let me rub this out now, that gives us 2 upon 3 is equal to minus 1 upon E, reciprocate both sides, so we get 3 upon 2 is equal to minus E, multiply both sides by minus 1, so we get E is equal to 3 upon 2 is minus 1.5. Okay, so price elasticity of demand will be what we call minus 1.5, so this option is correct. Next question is on the input-output model. The question is, the input-output matrix for two-sector economy is being given by us as A is equal to 0.25, 0.4, 0.1 and 0.1. This is our input-output matrix. If the external demand for the outputs of the two sectors is being given us as D is equal to 10 and 20, which is column matrix, we are supposed to find out the optimal levels of the two commodities. Okay, I will not go into the explanation what is meant by input output model. Here I will only solve the question. For that I will make a separate video what is meant by input output model and what are meant by the terms that we use in input output model. Okay, So we have the technology matrix or input output matrix, which is A is equal to 0 0.25, 0 0.1, 0 0.4, 0 0.1. Okay. Also, we are being told that final demand is 10 and 20. First thing is what we do, we form the Leontief matrix. So Leontief matrix is being formed by, we write the singular matrix minus, we subtract the technology coefficient matrix, that is A. This will be our Leontief matrix. So we have 1 0 0 1. To this we subtract 0 0.25, 0 0.1, 0 0.4, 0 0.1. So we will get 1 minus 0.25 is 0 0.75, 0 minus, so it is minus 0 0.1. Here we have also minus 0 0.4. Here 1 minus 0.1, it is 0 0.9. Okay, this is our Leontief matrix. Now next step is we need to find out, or let me rub this now. Next step is, so I minus A is this. Next step will be to find out the determinant of this I minus A, which is Leontief matrix. Its determinant, as we know, we multiply these two elements first. So we have 0 0.75 times 0 0.9. To this we subtract the product of minus 0 0.1 times minus 0 0.4. So it will come out to be, when we solve this, it comes out to be this term 0 0.675 and this term comes out to be 0 0.04. It comes out to be 0 0.635. If it was 0, then the system was not feasible. Since it is not equal to 0, so we have the determinant of I minus A equaling this. Next step will be to find out the inverse of this matrix. For that, first we need to find out the adjoint of this matrix. So adjoint of Leontief matrix, that is I minus A. So how do we form adjoint in case of 2 cross 2 matrices? What we do, we interchange the elements that are on the principal diagonal, okay, and we change the sign of the non-principal diagonal elements, okay. So here we will get, so this 0.9 comes here, this 0 0.75 comes here. In this direction we only change the sign. If it is minus 0.4, it becomes plus 0.4. So if it is minus 0 0.1, it becomes 0 0.1. Okay. Now next is we need to find out the inverse, that is the inverse of I minus A matrix. So inverse is simply 1 divided by the determinant of the Leontief matrix I minus A times adjoint of I minus A. Okay. So can we write it like this? So determinant is 1 divided by 0 0.635 times this 0 0.9, 0 0.4, 0 0.1, 0 0.75. Okay. Now let me rub this out. So our I minus A inverse will be equal to, so dividing 0.9, 0.4, 0.1, 0.75 individually by 0 0.635, what will we get? We will get 1.42, 0 0.63, 1.16 and 1.18. Okay. Then to find out the optimal levels of output, so we use the formula, that is x, which is equal to x1 x2 is equal to, that is the inverse of I minus A Leontief matrix times the final demand. So final demand is D. So can we write it like this? D is being given us as 10 and 20, 10 and 20. So our X, which is X1, X2 will be equal to, so we have this matrix that is 1.42, 1.16, then we have 0.63, then we have 1.18. To this we multiply 10, 20. So multiplying, so we have matrix multiplication here. Since that these two matrices are conformable, that is matrix multiplication is defined. Why? Because the number of columns in the first matrix is equal to the number of rows in the second matrix, so we can do the multiplication here. So multiplying this with this row with column, so we get 1.42 times 10 plus 0.63 times 20. And what will be the order of the new matrix? So here we have 2 into 2, 2 into 2, here we have 2 into 1. So the order of new matrix will be 2 into 1. So we will have 2 rows and 1 column. So we need to write here next multiplication, that is 1.16 into this. So 1.16 into 10 plus 1.18 into 20. Doing this, what we will get? So our X, that is X is equal to X1, X2, it comes out to be, so here it becomes 14 point, I have done the calculation, 14.2 plus 12.6, this sums up to 11.6 plus 23.6, so we will get, adding them, 26.8 and 35.2. Okay, so this should be the value of optimal, at optimal, okay, value of X1 and X2, that is the value of the optimal levels of the two commodities. The question is how to find out whether a particular equation is unidentified, just identified, or over-identified. The question is, consider the following system of equations. We have three simultaneous, we have the three equations. Y1 is equal to alpha naught plus alpha 1, y2 plus alpha 3, y3 plus alpha 4, x1 plus alpha 5, x2 plus u1. Okay, so u1, u2 and u3, these are the residual terms, alpha naught, beta naught and lambda naught. These are the constants. Okay, so how do we find out the order condition for identified, exactly identified, or under identified? For that we use the order condition. Okay, so for order condition, what we use the order condition? Order condition tells us, and let me write it here. Let me denote some variables here. Let us say k. What is k? Or let me write it here, k minus m, and we have another g minus 1. Now let me explain all these terms. What is meant by k? This k denotes the total number of equations. This k denotes the total number of variables, whether they are endogenous or exogenous, in our model. M denotes the number of variables in a particular equation. G denotes the total number of equations in the model. Okay? Now, if we get it, the equality sign, then we have exactly what we call identified. The particular equation is exactly and what we call identified if this equality sign holds. If we have k minus m, if it is less than g minus 1, in this case we say the particular equation is unidentified. Similarly, if k minus m is greater than g minus 1, in this case we have our identified, the particular equation is our identified. Okay, now we are being told about the first equation. Okay, what will be the first equation? In the first equation, so what does k denote? K denote the total number of variables, whether they are endogenous or exogenous. Exogenous variables, as you know, they are determined outside the model, and endogenous variables are determined inside the model. So in particular, in the first equation, what will be the value of k? Rather, the value of k will be the total number of variables in the model. So we have y1, y2, y3, and then we have x1, x2, and I guess x3 is also somewhere. Okay, we have x3, x2, x1, and we have y1, y2, and y3. I guess total number of variables, whether they are endogenous or exogenous, or 6. These alpha naught, beta naught, gamma naught, these are not, these are the constants, and u1, u2, u3, these are the residual terms. They are not neither endogenous nor exogenous. Okay, so total number of variables in the equation, rather in the model, that is the value of k. K is, so k comes out to be 6 minus what is m? M denotes the number of variables in a particular equation. Since we are being told about the first equation, what are the variables here? y1, y2, y3, x1, and x2. So we have 1, 2, 3, 4, 5. So m will be 5. Now g, total number of equations is 1, 2, and 3. Let's write it here, 3. Okay, now 6 minus 1. 6 minus 1 is, 6 minus 5 is 1, and 3 minus 1 is 2. So this inequality holds. Okay, so that means first equation is unidentified. Okay, so the correct option should be A option here. Now here we can also see what about, so the question was only about the first equation. Let us say we are being told about the second equation. So what will happen in the second equation? So total number of variables in our model are 6, and total number of variables in the second equation are 1, 2, 3, 4. So in this case we will have 4. So let us write it here, 4. So here first we have 6, and m denotes the number of equations in a number of variables in a particular equation, which is 4. So 6 minus 4. Here we have g minus 1. So we have 3 minus 1. In the second equation, 6 minus 4 is 2. 3 minus 1 is 2. So the second equation is just identified or exactly identified. What about third equation? So in the third equation we have 1, 2, 3, 4. Again we have 4 variables in third equation. So we will have 6 minus 4, and here we have 3 minus 1. So we get 2 is equal to 2. So the third equation is also just identified. The question is to find out the elasticity of substitution of the constant elasticity substitution production function. The question is given the CS production function is y is equal to a1 x1 raised power p plus a2 times x2 raised power p whole raised power p, where x1 and x2 are the two factors of production, y denotes the output. We need to find out the elasticity of substitution. What is the formula for elasticity of substitution? Let me write it here. So elasticity of substitution is simply equal to the change in the input ratio, that is the factors of production x2 upon x1, divided by the change in the input price ratio, the prices of x1 and x2 times p1 upon p2, like we use the elasticity formula, divided by the input ratio x2 upon x1. Okay, this is the formula. How do we get this x2 upon x1? First, we know that for optimization, what we do, we equate the marginal rate of technical substitution between x1 and x2. It should be equal to input price ratio p1 upon p2. We know this very thing. Now MRTS, as we know, it is simply, so MRTS, as we know, it is marginal product of input 1 upon marginal product of input 2. It should be equal to p1 upon p2. Okay. Now what is mp1 upon mp2? It implies the partial derivative of production function with respect to x1. Similarly, mp2 means the partial derivative of production function with respect to x2. It should be equal to p1 upon p2. We know this thing also. So let us find out this derivative. Dy upon dx1 means the derivative of this function with respect to x1 first. So we use the power function rule. Exponent becomes coefficient, so we have p times a1 x1 raised power p plus a2 x2 raised power p whole raised power p minus 1 times, we apply the chain rule, times the product of the derivative of x1. That is, what is the derivative of x1? So p becomes coefficient, so we will get p a1 x1 raised power p minus 1 divided by the partial derivative with respect to x2. Again, exponent becomes coefficient, so we have this p a1 x1 raised power p plus a2 x2 raised power p whole raised power p minus 1 times, you applying chain rule, the derivative of x2 raised power p, so p becomes coefficient, then we have a2, then we have x2 raised power p minus 1. Okay, here this term gets cancelled, p and p gets cancelled, so we are left with a1 upon a2 whole raised power x1 upon x2 raised power p minus 1. If I reciprocate it, so it should be equal to input price ratio p1 upon p2. So can I write it like this? a1 upon a2 x2 upon x1. If I reciprocate, it will become 1 minus p. Simple thing, reciprocating the terms changes the exponent sign. Should be equal to p1 upon p2, which implies, let us solve for x2 upon x1. So x2 upon x1 whole raised power 1 minus p will be equal to, transpose this, it becomes a2 upon a1 times p1 upon p2, or x2 upon x1 whole raised power 1 minus p comes out to be a2 upon a1, transpose exponent, it becomes 1 divided by 1 minus p times p1 upon p2 whole raised power 1 divided by 1 minus p. Okay, I have transposed it this, so it will not remain here. Now let me rub this out. So we got this result, and let me write it here. x2 upon x1 came out to be a2 upon a1 whole raised power 1 divided by 1 minus p times p1 upon p2 whole raised power 1 divided by 1 minus p. Now using the elasticity formula, so we need to find out the change in the input ratio due to the change in the input price ratio times input price ratio divided by input ratio. So the derivative, let us differentiate this with respect to p1 upon p2. That means the derivative of x2 upon x1 with respect to the input price ratio, that is p1 upon p2. We need to differentiate this with respect to p1 upon p2. Again, the exponent becomes coefficient, so we have 1 divided by 1 minus p, or this p1 upon p2, it becomes coefficient a2 upon a1 raised power 1 divided by 1 minus p times p1 upon p2, and its exponent is subtracted by 1, so it becomes, so we have 1 divided by 1 minus p minus 1, so it becomes 1 minus 1, minus into minus is plus p, so minus 1 gets minus 1 plus 1 gets cancelled, we get p divided by 1 minus p here, p divided by 1 minus p. Okay, now use the elasticity formula. So dx2 upon x1 divided by d p1 upon p2 came out to be this term, that is 1 divided by 1 minus p a2 divided by a1 whole raised power 1 divided by 1 minus p p1 upon p2 whole raised power p divided by 1 minus p. To this we multiply p1 upon p2, p1 upon p2, and we divided by x2 upon x1. x2 upon x1 is this term, so let's write it again. So we have a2 divided by a1 whole raised power 1 divided by 1 minus p times p1 upon p2 okay, so it is here 1 divided by 1 minus p. So elasticity of substitution will be equal a2 upon a1, this gets cancelled first. Okay, then first we have 1 divided by 1 minus p, then we have this p1 upon p2 whole raised power p divided by 1 minus p, then we have this term p1 upon p2, let's raise it to the power 1. If I transpose, the exponent sign changes, so we have p1 upon p2. If it is 1 divided by 1 minus p, it becomes minus 1 divided by 1 minus p, or elasticity of substitution will be 1 divided by 1 minus p. So here we have p1 upon p2 whole raised power p divided by 1 minus p. So bases are same, we can add the exponents here, so we get 1 minus, so we have 1 minus 1 divided by 1 minus p, so we get here 1 minus p minus 1, so this gets cancelled, so we get p1 upon p2 whole raised power minus p divided by 1 minus p. Okay, so again we have 1 divided by 1 minus p, again adding the exponent, so we have p1 upon p2 whole raised power p divided by 1 minus p. To this we add this minus p divided by 1 minus p, so this gets cancelled, so it becomes 0, so we have 1 divided by 1 minus p times, so p1 upon p2, so p1 upon p2 raised power 0, so we get elasticity equal to 1 divided by 1 minus p, anything raised power 0 is 1 times 1, so elasticity of substitution will be equal to 1 divided by 1 minus p. I have explained how to derive it here. The question is, 6 number of dice are simultaneously rolled. What is the probability that each face shows up with different numbers? Options are being given, we need to find out the correct option. Okay, so since we have the 6 dice being thrown simultaneously, then the total sample space will be equal to the number of dice, that is the number of faces in each die, that is we have 6 in first, we multiply them 6 times 1 2 3 4 5 and 6, so it will be equal to 6 raised power 6. This is our total sample space. Now we have to find out the probability that each face shows up with different number. Okay, so let us say we have 1 2 3 4 5 and 6 dice. Okay, so since the numbers should be different, let us say 1 2 3 4 5 6, this can be one combination. Similarly rather this can be one order, another order can be 6 5 4 3 2 1. Okay, so we need to find out different orders. For that we use simple the factorial. Factorial gives us the number of different orders that we can get. Okay, that means our probability will be equal to 6 factorial divided by 6 raised power 6, or we can write it like this: 6 into 5 into 4 into 3 into 2 into 1 divided by 6 raised power 6. Since the answer is in this format, so this option is correct. Next question is, given the matrix A is equal to 2 0 4 1 3 1 and we have another matrix B is equal to 4 5 0, which of the following is or true? Options are being given, we need to find out the correct options or option. So we have the matrix A is, we have 2 0 4 1 3 1 as the elements in the matrix A. In the matrix B we have the element is 4 5 0. Let us see the first option. First option says the product of A times the transpose of B is 8 19. That is, we have the column matrix with elements 8 and 9. Let us check the first one. So in the first one, so A is this, so can I write A B transpose is equal to, so we have 2 0 4 1 3 1. Now what is the transpose of B? So by transpose of a matrix we mean when we interchange column with row or row with column, we get a transpose. So if these are here rows, okay, row matrix, it becomes column matrix. So we have 4 5 0. Interchanging rows with columns or columns with rows gives us the transpose. Now the product of these two, first we need to see whether the product is defined or not. Okay, so for two matrices, rather for two matrices, the product is defined if the two matrices are conformable for multiplication. Okay, so by conformability, what we mean? By conformability, we mean that the number of columns in the first matrix should be equal to the number of rows in the second matrix. Or we say A and B transpose, the product is defined or exists when the number of columns in the first matrix is equal to the number of rows in the second in the second matrix. So what are the number of columns? 1 2 3. And what are the number of rows in the second? 1 2 3. Okay, so the order is here. We have 2 by 3, and here we have 1 2 3 3 by 1. Okay, since the number of columns is equal to the number of rows, the two matrices are conformable for multiplication, so we can do multiplication. And what will be the order of the product of the matrix? That will be equal to 2 into 1. So we will get 2 into 1. That means we will have 2 rows and 1 column. So let's do the multiplication. How do we do the multiplication? We multiply rows with the columns. So this row is to be multiplied with this column. So we get 2 into 4 plus 0 into 5, 0 into 5 plus 4 into 0. Similarly, we get, then we multiply this row with this column. So we have 1 into 4 plus, then we have 3 into 5 plus, then we have 1 into 0. Here you can see, and if I write it here, so we get 2 4s are 8. So this is 0, this is 0. So we get 8 here. Here 4 1s are 4, 5 3s are 15. 15 plus 4 is 19, and it is here 0. So we get 19. Now let us see the order of this matrix. So we have 2 rows and 1 column. So 2 into 1 is the order of this very matrix. That means option A times the product of the transpose of B is equal to 8 upon 19. This option seems correct. Now let us check the another, because here the multiple options can be true. So first one is true. Let us go for the second option. Second says as A B transpose is defined. As I have told you earlier that since A times BT, that is the product of A and the transpose of B, the product of these two matrices is conformable. If it is conformable, that means the product is defined. Okay, earlier we saw that we can do the multiplication with A times the transpose of B. So this option is also correct, because AB is defined if the product is conformable. Conformable means simply if the number of columns in first matrix is equal to number of rows in second matrix. Okay, I will not repeat it. So if the product is we say two matrices are conformable if they are conformable for multiplication. When this condition happens, if they are conformable, that means they are defined. Since we saw in the earlier option the product came out to be 8 upon 19, so it is defined. Let us see the third option. So we have B times A. So first we write 4 5 0 and we multiply it with A is 204 131. Here, for the two matrices to be conformable for multiplication, what is the condition? Number of columns in the first matrix should be equal to the number of rows in the second matrix. We have 1 2 3, we have 3 columns here, but we have only 2 rows here. Okay, so they are not conformable, that means they are not, the product is not defined. So this option is incorrect. Now let us see the last one. Last one says B times A transpose. B times A transpose. Okay, so B is this 4 5 0. This is our matrix, and the transpose of A, interchanging rows with columns. So we have 204 204 column, then we have 1 3 1. Okay, this is A transpose. Let us see the conformability. Number of columns in the first matrix are 3 and number of columns in the second matrix are 3. That means we can do the multiplication, and the order is here 1 into 3, and here 1 2 3 into 2 3 into 2. Okay, so the order of the new matrix will be 1 into 2. That means we will have 1 row and 2 columns. So let us do the multiplication. So we multiply row by column, so we get 4 into 2 plus 5 into 0 plus 0 into 4. Okay, so 1 row, then we have 2 columns. So this is 1, another will be here then, because we have 2 columns. So this is 1 number, we will have another here. So now we have 4 into 1 is 4 into 1 plus 5 into 3 plus 0 into 1. 0 into 1. Okay, let me write it here. Plus 0 into 1. And this will be our matrix. So this is 4 2s are 8. This is 0. This is 0. Here we get 5 3s are 15 plus 4 is 19. So we get 19. Here you can see the order is 1 into 2, 1 row and 2 columns. So this option is also correct. So we have 1 2 and 3. I don't see if there was another option, so I guess E option was also, I didn't write it here and I don't know this time.
Next question is, given the objective function y is equal to f of x1 x2 up to xn and constant g of x1 x2 up to xn is equal to 0, the second order condition for extremum is we need to find out. So what is extremum? Either we should get a relative minimum, or relative maximum. Okay, now what are the conditions? If H2 which is second ordered bordered principle, if its determinant is less than 0, and similarly H3 if it is also less than 0, so on up to Hn nth ordered bordered principal minor, if all are less than 0, we get a positive definite matrix, and positive definite matrix satisfies the sufficient condition for relative minimum. On the other hand, if the second ordered border principle, that is H2, if the first is greater than 0, if second, that is H3, if its determinant is less than 0, that means if the bordered principal minors determinant alternate their signs from positive to negative, we get a condition of negative definite matrix, and it satisfies the condition for relative maximum. Okay, let us see in the options what we are being given. So we have H2 less than 0, H3 less than 0. So it says it is a maximum. No, it is not maximum, so this option is incorrect. In the second, H2 greater than 0, H3 less than 0, this satisfies the condition for maximum. This is correct. Now C option, H2 less than 0, H3 greater than 0. So I have told you for relative maximum, our second bordered principal minor should be greater than 0. Since it is less than 0, so this does not satisfy any condition whether for the relative maximum or minimum. What about D? H2 less than 0, H3 less than 0. This satisfies the condition for minimum. This is correct. And what about the last option? H2 less than 0, H3 less than 0. It also satisfies the condition for minimum. So this is also correct. So we have B, D and E. But we don't have here. We have only A and D, C and E, B and D, and B and E. Okay, so I guess there is some problem in the question. So here B and D, it is also correct. B and E, it is also correct. Okay, so it seems there is problem in the question. Next question is, arrange the following events in increasing order of their probability of happening. Okay, so first is probability of getting two heads in a simultaneous toss of two coins. Okay, since we have two coins, so if we simultaneously toss them, so our space will be either we will get head on both, head on first, tail on second, or head on first, or we get tail and tail. So in this case, so favorable event is HH, that is 1 divided by total number of events is 1, 2, 3, 4. So we get 1 upon 4. So here we have 1 upon 4 for the first one. Now in the second one, we have to find out the probability of getting a queen from a single draw of a card from a well shuffled pack of cards. Okay, so number of queens in a deck of cards are 4. So favorable outcomes are 4, and total number of cards is what we call 52, I guess. So it is equal to 1 upon 13. Okay, so for the second we have 1 upon 13, 1 upon 13. In the third one, we have the probability of getting white ball from a bag containing 3 white balls and 7 black balls. So number of favorable cases are here, since we have to find out the probability of white ball. So we have 3 white balls, that is the favorable cases, divided by the total number of cases, that is we have 3 plus 7, which is 10. So we get 3 upon 10 here, 3 upon 10. So for the third one, we have 3 upon 10. For the last one, probability of getting an even number from single roll of failed dice. Okay, so how many even numbers are on a die? Six sided faced die. So we have 2, 4 and 6. That means we have 3, that is favorable events divided by the total number of events are we have 6. We know that there are 6 faces, so divided by total number of events, that is 6, rather the sample space, which is 1 upon 2. So for last one we will have 1 upon 2. Now let us write them in ascending order. So lowest among all is 1 upon 13, 1 upon 13. So 1 upon 13 is for queen. That means first we should get B. Okay, so first we should get either this. Then we have 1 upon 4, 3 upon 10. So 3 upon 10 is less than 1 upon 4. So 3 upon 10 is for C. So we get C, B, C. A is 1 upon 4. Then we will get 1 upon 4. And lastly we get 1 upon 2, which is D. So the correct option should be third option if I write them in ascending order of the probability of happening. Next question is, when CIG stand for consumption expenditure, investment expenditure and government expenditure respectively on domestically produced goods and services, and X and M stand for aggregate values of export and import for a country respectively, GDP is calculated as, options are being given, we need to find out the correct option. Okay, so what is the GDP equation? So GDP equation is equal to the consumption expenditure plus investment expenditure plus government spending, that is government expenditure, plus net exports. What is net exports? That is NX. Okay, the value of NX is export minus import. Okay, so the correct option in this case should be option 1, that is this equation denotes our GDP equation.